In this second installment of the energy unit, we're going to discuss exothermic and endothermic chemical reactions. Now, they mean the same thing, but the thought process is a little bit different, right? If you're not thinking of the thought process by way of definition. So exothermic still means what it meant before. A releasing of heat, an exiting of heat. And endothermic means exactly what it meant before. Reactions that absorb energy, an entering, an increase in heat. Now, when it comes to a chemical reaction, we're describing the surroundings around this reaction. So something that is an exothermic reaction is releasing heat. And in these types of things, we are going to feel the heat from that reaction. The temperature of the surrounding, right, is increasing. A fire is the best example for this. Fire is an exothermic reaction. It is constantly releasing heat. The reaction itself is releasing heat over and over and over again, and we feel that heat, which is why our temperatures increase. Now, in this reaction, we're kind of experiencing an endothermic reaction because we're the ones that are absorbing the heat. But the fire itself is the releaser of the heat. And when we start to write this into equations, we would write the word heat or energy or a value, maybe 800 kilojoules, joules being the unit of heat. Right? One of those three things would be written as a product in the reaction because it is a result of the reaction. Energy is being produced. An endothermic reaction is a reaction that absorbs heat. So the reaction itself is going to take all the heat in, which in turn would be taking all the heat away from the surroundings. Right? So the temperature of the surroundings would be decreasing. These things feel cold because they're just sucking in all of the heat. Now, in turn, I don't want to actually get too deep down this heat transfer, but an ice pack, one of those instant ice packs, we'll even write instant, the one that you crack open and then it all automatically starts to get cold. It does that because the reaction inside, when the chemicals are mixing, they start pulling in all of the heat. And so to us, the ice pack feels cold because the majority of where they're getting their heat from is from your body. And so what we do here is we write heat or energy as a reactant. Again, just like before when we were talking there, heat could be written as heat. It could be written as energy. It could also be written as a value, 800 kilojoules. One of those things would have to be written as a reactant as it's going into the reaction as we go. There's a new term that comes along with this, and that is the heat of reaction, which we represent as delta H. Delta meaning change. H being the letter representing the heat of reaction. This is going to kind of give us a value, a standalone number, so that we can know if something is exothermic or endothermic. And when delta H is positive, it's basically saying that the amount of energy has increased. And the only way that we could have the amount of energy increase is by having it absorbed. So endothermic reactions have positive delta H's. Exothermic reactions have negative values because they've lost the total amount of energy that they have that have been produced that have gone on within their chemical bonds. So that's kind of how chemical reactions work with exothermic and endothermic reactions. There'll be another video to continue on with the energy unit coming up.